Welcome everyone, and thanks for joining me today. I'm Anna Lyushchenko, mobile development expert, passionate about quality software from Ukraine. I'm Google developer expert in Dart and Flutter and Women Tech Makers ambassador. I currently work in the UK fintech company called Tide as senior staff engineer. I talk a blog about cross-platform development, contribute open source, and mentor. If by the end of this session you become curious to learn more about the topic, follow me on socials where I constantly share useful content. Today I'm excited to talk about Flutter, an open source framework by Google that is revolutionizing the way we build applications. As stated on Flutter's official website, it is designed for building beautiful, natively compiled, multi-platform applications from a single codebase. Since its official release in 2018, Flutter has gained significant traction among developers worldwide. Today we have hundreds of thousands of applications in production built using Flutter, and it has become one of the top choices for cross-platform development. These are the data from the Flutter team at Google announced this January. The popularity of Flutter can be attributed to its ability to deliver high-performing and visually appealing applications across various platforms. In this presentation, we'll explore Flutter from three different perspectives: how it can be used to support all platforms, how it can satisfy needs of different user groups, and become the one love for many developers. So let's dive in and explore the world of Flutter together. Let's first focus on its incredible ability to support multiple platforms. One of the key advantages of using Flutter is that it allows developers to write code once and deploy the same codebase across various platforms, including Android, iOS, web, Windows, macOS, Linux, and embedded devices. So instead of developing multiple applications with different codebases for each platform, developers can save time and effort by using Flutter to create a consistent and high-quality user experiences across all platforms. This not only simplifies the development process, but also reduces the chances of introducing platform-specific bugs and enables reaching feature parity. And users can expect the same look and feel, responsiveness and performance no matter which device they are using. This cross-platform support is made possible by Flutter's unique architecture. Flutter architecture is comprised of three main layers: the framework, the engine, and the embedder. The framework layer consists of the UI components, animations, and gestures that developers use to build user interfaces. Flutter uses a reactive and declarative programming style, making it easy to create and manage complex UIs. The powerful difference between Flutter and other cross-platform frameworks is that it controls each pixel of the screen and paints UI components similar to how they would look in a native operating system, instead of relying on binding mechanism. This allows to reach UI consistency across platforms and versions of operating systems. The engine is responsible for rasterizing composited scenes whenever a new frame needs to be painted. It provides the low-level implementation of Flutter's core API, including graphics, text layout, work with file and networks, plugin architecture, and Dart runtime. And finally, the embedder is a platform-specific code that connects the engine to the underlying operating system. This layer allows Flutter to access platform-specific features. Flutter applications are packaged in the same way as any other native application, so the hosting operating system cannot tell the difference. We developers mostly interact with the framework layer only, but together these three provide a seamless development experience and enable Flutter to create beautiful and performant applications on a wide variety of platforms. Flutter offers seamless access to a wide range of platform-specific functionalities, thanks to extensive library of plugins developed by the Flutter community. It allows developers to easily integrate native platform capabilities such as Bluetooth, payments, location, notifications, and many others. So we can create truly versatile applications that meet user expectations regardless of the platform they are using. Flutter is well suited for creating different types of applications, such as social networking apps, e-commerce apps, productivity tools, entertainment and media apps, health and fitness apps, and many more. This is the screenshot from the official Flutter Showcase gallery, where they feature marketplace apps from eBay and Alibaba, business apps from BMW and ByteDance, payments with Google Pay, 2D games, apps with Rich UI, generative art, and even Toyota infotainment system running in their cars built with Flutter. Flutter provides a rich set of built-in widgets, which are the basic building blocks of the user interface. These widgets can be customized and combined to create unique and engaging UI. And thanks to Flutter controlling each pixel on the screen, it enables creating stunning custom UI, like on this demo. This is a mobile app that allows users to navigate the intersection of history, art, and culture by exploring the wonders of the world. Wanderers app leverages stunning illustrations, engaging interactions, and amplified animations to bring the wonder of these sites to life directly. Wanderers is an example of the quality of user experience possible to build with Flutter. Wanderers app designer says that Flutter gives her a blank canvas with limitless possibility, allowing to design without compromise. This enables exploring a variety of unique interfaces in Wanderers: the full-size hero carousel for navigating between Wanderers, a resizable timeline to explore Wanderer construction and historical events, and the typographically rich informational section. She knows that whatever crazy idea she comes up with in visual design, typography, custom interactions, or animations, the developers team can make it work with the tools and flexibility provided by Flutter. Here I would like to highlight the importance of accessibility. It is a crucial aspect of applications development, as it ensures that your application can be used by people with different abilities. Building accessible applications not only creates a more inclusive user experience, but also broadens the potential user base, reaching more people and having positive social impact. Flutter is designed with accessibility in mind and offers many accessibility features out of the box. Some of these built-in features include support for screen readers like TalkBack on Android and VoiceOver on iOS, making it easier for visually impaired users to interact with the application. Users with vision difficulties can scale the text size according to their preference in device settings, and Flutter ensures that the application layout adapts accordingly. It also supports keyboard navigation and other assistive technologies. Developers can provide semantic labels for interactive elements, making it easier for screen readers to communicate the purpose of each element to the user. When building custom UI components, Flutter makes it easy for developers to add new accessibility features or modify existing ones. The framework provides a flexible set of APIs and tools that helps developers create accessible applications with ease. By leveraging Flutter's built-in accessibility support and following best practices, developers can create applications that cater to a diverse range of users and create a more inclusive digital landscape. Now let's shift our focus to the benefits of using Flutter for developers and why I say Flutter is for all. Let's start by exploring Dart, the programming language that powers Flutter. First of all, Dart has been specifically designed to enable a unique and enjoyable development experience. It shares similarities with many C-like languages, making it easy for developers from different backgrounds to learn and adapt to it quickly. Here are a few examples of the code written in Dart from the official website. If you have experience with one of the popular programming languages, chances are you are already somewhat familiar with Dart. One of the key features of Dart is its support for both ahead-of-time and just-in-time compilation types. For apps targeting mobile and desktop devices, Dart includes both Dart VM with just-in-time compilation and an ahead-of-time compiler for producing machine code. For apps targeting the web, Dart can compile for development or production purposes. Its web compiler translates Dart into JavaScript. This combination provides several advantages to developers. Just-in-time compilation enables a faster development cycle, as the code can be compiled and executed on the fly. This allows developers to see the results of their code changes almost instantly, without the need for a full recompilation. With just-in-time compilation, Flutter's stateful hot reload feature allows developers to see the effects of their code changes in real time, without losing the application state. This significantly speeds up the development process and helps developers iterate more quickly, leading to faster prototyping and reduced time to market. At the same time, ahead-of-time compilation allows Dart to generate high-performing, natively compiled code for production. This ensures that Flutter applications deliver excellent performance comparable to native applications on various platforms. Ahead-of-time compiled code can be executed directly by the target platform, without the need for an interpreter or a runtime. This results in faster application startup times and a more responsive user experience. Ahead-of-time compilation generates platform-specific binaries, which tend to be smaller than binaries generated by just-in-time compilation. This can lead to reduced application size, making it easier for users to download and install your app. This combination allows developers to enjoy the benefits of the fast development cycle with stateful hot reload, while still being able to generate high-performing, natively compiled code for production. Another great aspect of Flutter is its inclusive and comprehensive documentation. Regardless of your programming background, Flutter documentation has something to offer you. It has numerous tutorials, sample projects, and learning resources, making it easy for developers to get started and find solutions for common issues. Flutter documentation is designed with a diverse range of developers in mind. One particularly useful section is dedicated to developers coming from other frameworks. Here, developers familiar with platforms such as Android, iOS, Web, React Native, and Xamarin can find specific guides that leverage their existing knowledge to help them get up to speed with Flutter quickly. Each guide discusses how the concept you are already familiar with maps to Flutter's approach, and offers practical examples and code snippets. This approach allows developers to build upon their existing knowledge, making the learning curve less steep and transition smoother. Flutter and Dart together provide a highly productive development experience. I have already mentioned stateful hot reload, which allows developers to see the results of their code changes in real time without losing the application state. This speeds up the development process and helps developers iterate more quickly. Dart strong typing and null safety features help catch potential errors early in the development process, reducing the likelihood of runtime crashes and making the code more maintainable. Flutter uses reactive and declarative programming style and a widget-based approach, which simplifies UI development, making it easy to create and customize complex user interfaces. Flutter offers a rich ecosystem of tools that streamline the development process and help developers create feature-rich applications with ease. Flutter has support for popular IDEs such as Visual Studio Code, Android Studio IntelliJ IDEA, providing features like syntax highlight, code completion, and debugging tools. Also, there are a few online tools like Dartpad and Zap for Dart and Flutter development. Flutter DevTools is a suite of performance and debugging tools that help developers identify and fix issues related to rendering, performance, and memory usage. Flutter community has developed a wide range of packages and plugins that provide pre-built functionality for common tasks such as network requests, image handling, and database management. This enables developers to focus on building their unique features without reinventing the wheel. And lastly, and this is my favorite, Flutter has a large and active community of developers who contribute to the ecosystem, share their knowledge, and help each other solve problems. This is a very supportive and inclusive community, and to me, it's simply the best developers community ever. With all that said, now let's take a look at the demo. Here I have my Android Studio running, as well as Android Simulator and iPhone Simulator. I will create a new Flutter project, hit next, let's call it demo. As you see here, I have a selection of platforms I want my application to support, and I will keep all of them. And let's hit create. And now we have our first Flutter application created. I will immediately hit run because it takes some time for the first run. And meanwhile, we can explore the project structure. Here on the left, you can see folders dedicated to all native platforms: Android, iOS, Linux, macOS, web, and Windows. So these folders contain native code, which then allows our Flutter code to run inside. And we already have our application running on Android emulator. I can click this button and I see the counter updates. You have pushed this button this many times. And we also have see an app bar, which looks pretty much like a standard Android app bar. I will now run this on my iPhone simulator. And meanwhile, we can explore the code. Basically, that is the all code of my application. It's located in this lib folder where all the Flutter code is located. And this is the function that launches the application. And as I said, Flutter offers a rich set of widgets. If I scroll a bit, let's see, we have floating action button, which is a widget. It corresponds to this button, which I was pressing. We have a couple of texts. You see text, you have pushed the button. You see text displaying the private variable, which is updated every time I push the button. And we already see the application running on the iPhone. And I can also click this button. Let's now run this application on macOS. And you see, I don't stop the execution of programs, and we already have 3 of them running. And it shouldn't take long. And we already have it running on macOS. And I can also click some buttons. And finally, I will demonstrate how it runs on web. I also have created a project to support Windows and Linux. However, those are desktop applications. To run desktop applications, I need the operating system where to run them, and I only have my Mac with me. Web project has run. It opens window in a different desktop, so here I brought it up to the screen. And I now have 4 instances running, and let me show you something cool. I will now find the place where the main color of the application is set. It's currently blue. Let's make it green. And I will hit the magic hot reload all devices button, and we immediately see all of the application became green. And as you see here, the results of my clicks remained So that is the Flutter stateful hot reload in action, which enables the very productive development experience. And that's it for the demo, and thank you for your time. I hope you get inspired, and happy fluttering!